This is question number 5 from miscellaneous exercise of chapter 13, probability. The question is, an urn contains 25 balls of which 10 balls bear a mark X and the remaining 15 bear a mark Y. So we have an urn which contains 10 balls and 10 balls are such which are marked with this letter X and remaining 15 balls are marked with the letter Y. A ball is drawn at random from the urn. It is marked, its mark is noted down and it is replaced. So what we are doing, we are selecting a ball at random from the urn. We are checking what is written on it, X or Y. It is noted down and it is kept or it is replaced back in the urn. If 6 balls are drawn in such a way, find the probability that in the first part all will bear X mark. Second, not more than 2 will bear Y mark, and so on. Okay, now to solve this question, let P be the probability that a ball has mark X. A selected ball has mark X. So this will be equal to 10 upon 25 because there are total number of balls which are 25 and there are 10 balls which are having X written on it. So 10 upon 25 or 2 by 5 will be the probability that a ball which is selected has mark X, and Q is the probability that the ball selected has a mark Y, and this would be equal to 15 upon 25 or 3 upon 5. Now 6 balls are drawn with replacement, therefore the trials are Bernoulli's trial, and let Z be the number of balls marked with X in 6 trials. Okay, now as we are drawing 6 balls with replacement, then the trials would be Bernoulli's trial, because if probability of selecting a ball with mark X is a success, then selecting a ball which is not going to have a mark X would be a failure. So if P is the probability of success, then Q is the case in which a ball having mark Y has been selected, so this is the probability of a failure. So each trial has 2 outcomes, that is success or a failure. Okay, and the probability of each trial, or that is probability of success for each trial, is going to remain same. There are 6 number of trials and each trial is independent. Outcome of each trial is independent. So therefore the 6 balls which are drawn with replacement under the given condition represents Bernoulli's trial. Let Z be the number of balls marked with X in 6 trial. Okay, so therefore Z will have a binomial distribution with in P and N, and where P will be equal to 2 by 5 and N will be equal to 6. And the probability of Z successes would be given by ncz P to the power of Z Q to the power of N minus Z. Now in the first part, we are required to calculate the probability that all balls bear mark X. Okay, so this would be equal to probability of exactly 6 successes. Okay, because 6 out of 6 balls are such that they are marked with X. So this would be equal to probability of exactly 6 successes, and this would be equal to 66 2 by 5 to the power of 6 into 3 by 5 whole to the power of 6 minus 6. So we have applied the formula of exactly Z successes in N trials, and this is P, this is Q, this is NCZ, and this is N, this is N minus Z. Okay, so 66 is 1, 3 by 5 to the power of 6 minus 6 would be equal to 3 by 5 to the power of 0. So this would be equal to 2 by 5 whole to the power of 6. So this is the required answer to the first part. In the second part, we have been given not more than 2 will bear mark Y. So we are required to calculate the probability that less than or equal to 2 number of balls should bear mark Y. And this would be equal to probability that no ball bears mark Y plus probability that 1 ball bear mark Y plus probability that 2 balls bear mark Y out of, in all these cases, 6 balls, when 6 balls are being selected. Now it is very interesting to note that when no ball will bear mark Y, then all balls are going to bear mark X. Okay, so this would be same as probability all the ball bear mark X, and this would be equal to probability of exactly 6 successes. Okay, and similarly here, probability that one ball bear mark Y would be same as probability that exactly 5 balls bear mark X. So this would be equal to probability of exactly 5 successes. And similarly, the probability that 2 balls bear mark Y would be same as probability of exactly 4 successes. And probability of exactly 6 successes can be written like this. Probability of exactly 5 successes can be written like this. Probability of exactly 4 successes can be written like this. So this is 66 p to the power of 6 and q to the power of 6 minus 6. Okay, and here we have to replace 1, 2, 3, these 3 places where 6 are written with 5 to get probability of exactly 5 successes, and similarly probability of getting exactly 4 successes. Okay, now we have to solve them. So this we have already solved, equal to 2 by 5 whole to the power of 6. Here this 5c6 would be equal to 6, and this 3 by 5 would be 3 by this 3 by 5 whole to the power of 6 minus 5 would be 3 by 5 to the power of 1. So this would be equal to 6 into 3 by 5 into 2 by 5 to the power of 5. 64 is equal to 15, so this would be 15, and this 3 by 5 whole to the power of 6 minus 4 will be equal to 3 by 5 to the power of 2 into 2 by 5 to the power of 4. From these 3 terms or values, we can take 2 by 5 to the power of 4 common, and here we would be left with 2 by 5 to the power of 2, so this would become 4 by 25. Here we would be left with 6 into 3 by 5 into 2 by 5, so which on multiplying give me 36 upon 25. Here we would be left with 15 into 3 by 5 whole square, or 15 into 9 upon 25. So 15 into 9 is 135. So we are going to get 135 upon 25. Adding all these 3 terms, I am going to get 2 by 5 to the power of 4 into 175 upon 25. This cancels with 25 7 times. So this would be equal to 7 into 2 by 5 whole to the power of 4. Which is the required answer to the second part. In the third part, we have to find the probability that at least one will bear mark Y. Okay. So this will be same as 1 minus probability that none will bear mark Y. Okay, so whenever we have to calculate at least one will bear mark Y, so this would be equal to its complementary event, that is equal to 1 minus probability that none will bear mark Y. Okay, and probability that none will bear mark Y would be same as probability that all will bear mark X, and this we have been calculated, this has been calculated by us as 2 by 5 whole to the power of 6. So probability that at least one will bear mark Y would be equal to 1 minus 2 by 5 whole to the power of 6. And in the fourth part, we are required to calculate the probability that both balls marked with X and Y are equal in number. So because there are total 6 balls, so we are required to calculate the probability that what is the probability that we have 3 balls marked with X and 3 balls marked with Y, and this would be equal to probability of exactly 3 successes, because if 3 balls are marked with X, then 3 balls will also then remaining 3 balls will be marked with Y. Okay, and probability of exactly 3 successes would be equal to 6c3 into 3 upon 5 to the power of 6 minus 3 into 2 by 5 to the power of 3, and this would be equal to 20 into 27 upon 125 into 8 upon 125, which is equal to 864 upon 3125, which is the required answer. So this is how I'm going to solve this question.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.